Welcome to Espresso and Electronics, quick sips of media wisdom. If you've been around the block in semiconductor design, you can imagine how time-consuming and resource-intensive is this entire verification process. But I think finally we have a breakthrough. We have a game changer, which is called as Verisium SimAI. And Verisium SimAI is an AI-powered platform which is designed to tackle the challenges, head on using machine learning to revolutionize how we approach design verification. To give us a deeper insights on how this technology works, what is the impact, how can DV engineers be, benefited with this, we have a special guest joining us today. John Rose is a leading expert in machine learning applications for semiconductor design. Welcome to the show, John.
Thank you, Annika. It's a pleasure to be here. That's quite the introduction. I think you may be overselling me a little bit, but that's all right. We'll go with what we have.
So, John, for our listeners today who might not be familiar with design verification, could you briefly explain what are the challenges, the traditional challenges that you feel exist in this space?
Yeah, I mean, the challenges really haven't changed for, I don't know, 50 years. It's been a long time, and we're still having the same essential challenges. And that is we create some design and we don't know if the design is correct, if it meets the spec. And so we have to verify it. And that verification takes time. And as the designs get bigger and bigger, you can't exhaustively verify. It's just not possible. So, over the years, there have been a lot of advances to try to help with this problem, right? You've had a random verification to kind of do some, random sampling to hit different areas of the design space, and that helps a lot. You have formal verification with model checking. That's great as long as your block that you're verifying is small enough and you've completely, provided the constraints associated with the area. But the fundamental problem is it is a huge space of all the possible things that could happen and you can't verify it all. And what that results in when we're talking about software verification specifically is it results in a lot of wasted compute, because it's kind of like you're just shooting in the dark. You've got you're in the woods, hunting for an animal, and you don't know where it is. So you're just going to, shoot everywhere and see what happens. And maybe you'll hit something. Maybe you will, maybe you won't. But it's very hard. And like I said, one of the big challenges is you end up hitting the same areas over and over and over again. So you're not really aiding to verification. And then, if you've got some hidden bug somewhere, well, I mean, your whole job is to try to find it, and it's a difficult problem.
Absolutely, John. Also, could you elaborate a little bit on, how does Verisium SimAI use machine learning to, change this typical scenario, right?
To try to help with that, yeah. So, at the end of the day, SimAI is not a panacea. It is a tool that helps, right? And it helps in a couple of ways. So what this technology does fundamentally is it learns about your randomization. So it's taking a random environment, something random already. And as I said, random environments, that the upside is they hit a lot of interesting things. The downside is they often waste a lot of effort doing the same thing over and over. So what SimAI does as a technology is it learns about your randomization. It understands or tries to understand what is happening with your randomization on the front end. And then it looks for interesting events, interesting signals that it can target. So right now, those interesting signals are coverage. So you've written some coverage. You may have some coverage that's difficult to hit, and SimAI can target that and try to steer runs into different paths to hit that interesting coverage. Or that coverage can be failure signatures. So you have some rare failure signature, and you use this technology to steer toward that failure signature. In the future, you can imagine many other kinds of interesting events that we'll be able to target to as well. But today that's what it does. And so, okay, so it does this. Now, what do you get out of it? Right? your question. So, how does this actually help you? And it helps in a few ways. So, one way is kind of obvious and what's been available in the technology for a long time, and that is it can efficiently do the same work that your more heavy regression is doing, and essentially get rid of the redundancy. So you have 10,000 runs in a regression, and SimAI says, yeah, I can get the same essential work done with, say, 3,000 runs, something like that. So that's an obvious thing it can do because it can see the patterns and get rid of redundancy. The less obvious, but maybe more interesting for DV engineers, is that it can stress the areas where the events are hit much less. So you have some coverage that's hit very infrequently. That indicates a part of the environment that's under verified. So SimAI can figure out, okay, how do I steer different kinds of random patterns toward that particular area? And so this is kind of the bug hunting mode. And an additional thing that we've found extremely effective is we can target failure signatures, as I said before. That works best when you're targeting very rare failure signatures. So I have a failure signature, it fails 2 or 3 times in the 10,000 run regression. So I have very few samples of it. If I check in the change, there's a lot of risk that I haven't really fixed it, that, providing the seed isn't enough to be confident that I've actually fixed it. Or there could be other bugs kind of lying in the area because this is a very rare failure. I found a bug that indicates that there is a corner condition that is really under verified. And so SimAI can help to direct in that way. So it's kind of taking this scattershot random regression, and it's helping focus in on some areas that are clearly of importance that you can use additional verification of. And then the last thing, sorry, I'm taking a filibustering here, but the last thing is the coverage maximization. So this is kind of the big thing that DB engineers are looking for. It's like, can you help me close my coverage? Because it's not so hard for me to get to 97% of my coverage, maybe 98%, but that last little percentage is very difficult. Now, I'm not going to say this technology is magic here, because it's not yet, maybe in 2 or 3 years. But what this technology can do is we have an iterative learning technology where we can focus on holes. So the tool does analysis of the holes that are remaining. It tries to understand structural relationships between those holes and the coverage space that you currently have. And then it uses its algorithms for steering toward these different areas of the design to target those areas that seem highly correlated to the holes. And what we're seeing with that is that we can close that gap. So we still, aren't likely to get to 100%. But if your regression, if you say, ran 1,000,000 runs of your regression and you could get to 99%, then with 3 or 4 iterations of SimAI, you'll get close to that same point, right? This is kind of the idea of this technology. As I mentioned before, you can envision many things that we can then build on top of this technology to even close further. So this is where we want to go with this, right? We really want to get to that 100% level. But right now, the goal is, okay, you're in coverage closure. Maybe it takes you 3 weeks to have your DV engineers every day writing new tests, analyzing, trying to figure stuff out. Instead, you run SimAI for 3 or 4 days in this iterative fashion, maybe while your DV engineers are also working, and you reduce the amount of work that the DV team has to do by half, for instance. That's the idea of the technology now, and I think that's a nice a nice piece of help, right? It's a hard part, a high stress hard part of the verification timeline, and SimAI can help in that respect.
Absolutely, John. I think this is really fascinating. I think, I mean, instead of all the DV engineers being blindfolded, right? I mean, I think this can be your, your kind of lighthouse or kind of your mentor, right? Who's actually hand
Right.
holding you to be directing you to the right thing, right? Rather than wasting time, it's letting you go into the right direction, right? So that you can maximize your
Yeah, I mean,
productivity.
that's right. That's kind of the idea, right? It's like SimAI doesn't necessarily know exactly how to hit a hole, but it can kind of figure out how to steer you in the right direction and give you traces that are going to be more interesting and get you toward it. And even if SimAI doesn't hit the hole, it may still produce runs that are helpful to DV engineers trying to figure out how they can get there as well. So, it does both of those things.
I like it. Yeah. So also, John, you mentioned something about cousin bug hunting. I mean, it sounds something like just out of a sci-fi movie, right? I mean, can you just elaborate a little bit more on what exactly is cousin bug hunting?
Yeah. So, I mean, the basic, so this is always, again, another problem that's been around forever is late in the verification cycle. Typically, the bugs that come out late are bugs that are really hard to hit. And so you're running, thousands and thousands of random regressions, and you hit a bug. And that's great. You've kept a bug escape from happening. But now you have this worry, this legitimate worry. I found this very rare bug. It's happened, and now what that bug tells you is not only there was a problem, but that I've got this under verified area of my design where there could be other bugs sitting there that are related. They're not the same, but they may be related to the bug I just hit. It could be that you have to go past that bug. Like once you fix this bug, there could be another one right behind it, right? Or it could just be it's a similar a bug that's of a similar style, right? Maybe you have to get the back pressure of the FIFO so that you go into some other part of the design, some other state machines, and then when you're there, you get into some state where that's where the bug lives. And there's also some other bug that maybe requires some other things to happen, and you still haven't seen it. So the idea of the cousin bug hunting is, well, okay, so now SimAI has information. It has information about how you hit this bug, this very interesting event. So can you use that information to build a set of runs that are going to steer those runs into the same general area, right? So the effect will be you will hit that one failure more frequently. So if you just run again, if that failure was say 1 in 20,000 runs, maybe you'll hit it 3 or 4 times in 20,000 runs, or maybe 1 in 10 times even, right? You'll hit it more. But more importantly for this discussion is all the runs are going to be kind of in the area, right? It's going to be trying to generate similar states, similar things happening that got you to the bug. So if there happen to be, latent cousin bug scenarios there, this technology is helping you, build a set of runs that are going to emphasize that. That's the idea, right? Now, again, the point is that you have found something interesting, a failure, a rare failure. That's an interesting thing. And now you're using this technology to focus into that area instead of the DV engineer having to say, how did I really get there? What's the interesting thing about everything I did up front that I can try to build runs that will be random around here? Because what DV engineers tend to do when they focus, they say, oh, hey, I need to write a directed test to hit that bug. They will tend to over constrain tests to just get to that bug. And that's good for verifying that one, sequence of things that happened, not as good for exploring, around the different areas. So that's the idea.
I am convinced, John. I think Verisium SimAI is the kind of productivity boost the industry needs, right? So, having said that, John, you've been working with multiple customers, right? And different people have different approach or ways to use the tool. Can you just tell us a little bit more on how customers are really leveraging the tool and how are they seeing the benefits, right? I mean, with all the use cases that you mentioned.
Yeah. So what I will say is, as I said, this compression, the regression efficiency piece, that's been out a long time, and so we have quite a few customers that are using for that purpose. And I will say for DV engineers, that's not the most interesting thing. It's it's an efficiency thing. It's and for many DV engineers, the feeling is, hey, I've got unlimited compute, but of course, in reality, you don't have unlimited compute. So yes, we have many customers using the technology where the basic methodology is, okay, once I get to the point where my coverage is pretty solid, it doesn't have to be, done, but it's pretty solid, and my regressions have gotten pretty large, so they're taking a lot of compute. What they do is on the weekends when they run, 3 nights worth of runs in order to do their heavy weekend verification, they'll use that information to train their model, and then they build a SimAI regression on that data, and then they'll run that for a week or 2 weeks. It depends on how much the verification environment's changing at this point as to how often that they'll retrain. But typically they'll retrain the model once a week or every other week, right? But anyway, what this gives them is it gives them a nice compressed set of runs to run during the week for their nightly regressions. And then they still run all of their complete random runs over the weekend the same way they were already doing. That's one approach people do. The other approach people do is they will keep their regression roughly the same as they currently do. And then they'll look at this technology for doing what I was talking about on the quote unquote bug hunting side of thing. They use it to stress particular areas of the design, whether it's low hit coverage, low hit failures, or some part of the design that's getting a lot of churn. They just tell the tool, focus on that. They get a set of runs, and then they add those runs in with their regression to give them, again, runs that are stressing some interesting kind of situation. So in that case, it's not so much about replacing the regression. It's more about saying, okay, here's my overall compute budget for my regression. I'm going to use maybe 20% of it for these SimAI runs that are doing a very focused, specific kind of effort. And I'll use 80% for more general, doing whatever I'm doing. So those are the two main ways people are using it. This cousin bug hunting is another thing. It's been available for a little over a year now, and we're seeing really excellent results with that. One of the nice advantages of that, where you're targeting failures, is you can use it anytime. You don't have to have any coverage in order to use. So we're finding people start using that aspect of the technology much earlier. Once the failure rate is low, and now when you have an interesting failure, it makes sense. You say, hey, okay, well, let's see if we can get some runs that are going to really stress this area. We're busy still writing our coverage model and trying to do interesting stuff, but we're still getting interesting failures. And that indicates we've got maybe some hole in our verification. Let's stress it and see what happens. And we're getting a lot of interesting use out of that as well.
Thank you, John. Makes total sense. Yeah. I think it's the era to work smarter, right? Rather than slogging yourself. I
Right.
mean, let the machines do what they're best at, right? So,
That's right.
yeah. And John, before we end, do you have any best practices that you would like to share with our listeners?
Yeah, I mean, I feel like I've been talking a lot for you, but but let's see. Yeah, I mean, this is like any technology, right? It's a tool, and really, the best practice for using this tool, just really like any other tool, is figuring out, what are you trying to get out of it, right? There is a place in your verification flow where this tool can help you save time, can help you say DB engineer time or compute time. And so it's really thinking about, okay, how do I want to use it? How do I want to build my runs, my software verification runs, so that I get the most out of them? So I have the most, really fully random tests. I have the most focused tests on interesting things. And, so as a best practice, that's really, that planning, it's the same kind of planning you do for all of your verification. When do I run UNR to, get rid of my uncoverable bins, right? When do I, on what parts of the design do I do formal verification? And then how do I reduce the amount of simulation effort I put on those things, right? All of these things really come down to the planning, like planning your verification and how do you use all these tools to make it better. And it's the same with SimAI, right? There's definite places in the verification process where it can provide help. It can provide aid to the DB engineer, and you want to use it in those places.
Thank you, John. Thank you so much for sharing your insights. It's been absolutely enlightening to have you on the show.
I appreciate it. Thank you very much for having me.
And I just want to let our listeners know that we also have a Verisium SimAI webinar, which is already available, and there is a pre-recorded demo also, which is available online. So I highly recommend all you listeners to check it out. We will have the link at the end of the podcast. And keep your circuits connected and your ideas flowing until we meet next time on Espresso and Electronics. Stay innovative.